Anastasia Maximova, Anna Moroz, Vladimir Kashurnikov, we all together from the National Research University, MIFI. The origin of this work lies in the study of our experimental research of levitation technique. Levitation technique is very interesting research because it's a real sample of application of superconductor, such as transport, levitation transport, levitation bearing, flywheel energy storage, and so on. And as superconductor element, bulk high TC materials and tape high TC materials was used. In contrast, in situation when the superconductor placed in the big solenoid with a uniform magnetic field, in the levitation technique, the source of magnetic field is a permanent magnet, and the distribution of magnetic field in the area of high TC elements is very inhomogeneous and non-uniform. And the main goal of our study is observe of finding the difference in the structure in the case of uniform and non-uniform external magnetic field. As we well know, the superconductor, high TC superconductor, have a layered structure with a copper oxide plane and vortex divided to the pancakes, which may interact together in the plane and interact between the plane. So, if we want to simulate the field distribution in the high TC superconductor in the non-uniform magnetic field, we need to take into account all possible interaction in such a system. Model for Monte Carlo calculations take into account vortex-vortex interaction, vortex-spin interaction, vortex-surface interaction, interaction with magnetic field, with Meissner current, vortex of energy, and this set of interaction is correspond to plane interaction, and for three-dimensional case we input the the interaction between the plates, between the layer and copper oxide plane. What is the result of such a simulation? The first result is a distribution of vortex pancake in the case of defect-free superconductors.
Microphone, please.
Sorry. In the case of non-uniform magnetic field, we can see non-uniform distribution of pancakes, and in case of uniform magnetic field, the distribution is have a common state as in a big solenoid. If we trace the position of the imaginary vortex filaments, we can see that it begins at the surface Oh, sorry. This one. Begin at the surface and exit from the bottom or the side of the sample. In the case of uniform magnetic field, the vortex line is almost straight. If we introduce defect to our sample in calculation, the distribution depends of concentration, and the distribution of pancake depends on concentration of defect and or from the pinning centers of defects. Let's consider the modification of vortex structure with an increase in magnitude of magnetic field, because in levitation technique the magnetic field change when the permanent magnet change the distance between the high TC sample and magnetic and permanent magnet. First of all, we set the upper magnetic field 300 Gauss, and vortex are concentrated near the top of the sample and almost absent from the below. The next case, 355 Gauss, concentration of vortex rises near the top and the of the sample, and some vortices appears on the bottom of the sample, and rise of external magnetic field lead to the increasing of the pancakes, and in case of 400 Gauss, the almost all sample is filled by the vortex pancake, as in the case of the uniform magnetic field. We can calculate the number of pancakes vortex in each copper oxide plane, and next slide shows such dependence of pancake number from the layer number. The full symbol belong to homogeneous field, and total symbol belong to homogeneous field. We can see that in case of homogeneous field, the number of pancake almost equal for different layer, and in case of homogeneous field, the number of pancakes rise, as we can see in previous slide. So it was our first result for this study, and the summary. The Monte Carlo method was used to simulate the vortex lattice in layer at high TC in a homogeneous magnetic field. We have obtained the vortex configuration found in the steps of conductor planes, analyze the case of UA defect in conductor. We show the dramatic difference of the vortex state in case of uniform and non-uniform field. And it's very important results that we estimate that the limiting thickness at which a sample we have as in homogeneous field is approximately 1 micrometer. And this result can be used for estimation of levitation properties of a real sum in the real sample with the real levitation devices.
Thank you for your interesting presentation, and a short question concerns your last remark. I think levitation properties are at the key of all possible applications, all existing applications. How close are you to this implementation of such samples in some device design, or it requires some longer work? Thank you.
Okay, it's a very interesting topic because for example, our results indicate that in small value of external magnetic field, almost all internal volume of the sample is free of the pancake. So we can optimize the mass Geberit size and properties maybe by удалять,
Making more,
making more, yes.
Yeah. Okay, thank you.